All right, so when you look at the information that you're provided, you have 2008 corresponds to 8.61, and 2012 corresponds to 11.55. You're told that it's exponential growth, so you're going to look at this model. Well, the first thing to realize is that this represents a t equals 0. Okay, so that's what you're going to look at first. So the actual point is 0, 8.61 in terms of t and p of t. And then 2012 is going to be how many years past that? 4. And so 11.55 is what you get 4 years later. So when you set up and solve for your function here, right, you have a set of coordinates. So here's p of t and t. So you're going to plug that in here and here. So you have 11.55 is equal to, our a value is our original initial amount, right? So at time 0, our initial amount is 8.61, so that plugs in at a. Our b is our unknown, and then our t value is this length, or this measure 4. And so what we can do right here is we can solve for b. You can either set it into your calculator and solve for b, or you can manually solve this. If you divide by 8.61, those cancel, and then you extract this root, take the fourth root of both sides. And so instead of the fourth root here, because I'm using the TI-89, I'm going to go ahead and just take it to the reciprocal power, 1 over 4. So 1 over 4. And so when I do my calculation for this, I'm going to take 11.55, divide by 8.61, and then I'm going to take that whole thing to the power of 1 over 4. I put that in parentheses, and I get my answer. It's already in decimal, so it should display as a decimal. So I get 1.0762 is my b value if I round it to 4 decimal places. And so when I write my equation is going to be p of t is equal to my initial amount, which I saw was 8.61, times my growth factor, all to the t. And so this is the equation or the function that represents that model.